Don't make me laugh, Kayla. Hello, class. Of course, I'm Mr. Slaughter, and as Willie Williams will say, how you doing? You got the rational zero theorem that we're going to use today. Today, the rational zero theorem, basically, you find the rational zeros, the zeros of the function, the possible x-intercepts of the function across the x-axis. You got the last constant, okay, which is the last number in this polynomial function. All right, what you're going to do is list the plus or minus multiples, okay, of this number, factors, I should say. Okay, so we're going to start off with the 6. What are the factors of 6 possible rational zeros? We got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are my possible zeros. All right, that's what we're going to start off today. All right, now the rational zero theorem also states the plus or minus zeros of the leading coefficient, which is in this case 1. Okay, so we really don't have to do that one, because if I do plus or minus 1, all right, and then put these guys over this guy, you're going to get these guys back. All right, so I will go over that in a minute. But in this case, it's very simple. You just list if you have a leading coefficient of 1 in your polynomial function, you list you list the plus or minus factors of the 6 on the end in this case. Okay, so these 4, actually it's 2, 4, 6, 8 possibilities here. All right, now we're going to get to a live example. So if I give you, if you go to page 129, I'm going to give you an example. Let me erase this. Suppose I give you this. And the instructions say, list and find all the real zeros of the function. Okay, so I want to find all real zeros of the function. Okay, so what we're going to do is list all possibilities of the 18 on the end. So you got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and then we got plus or minus 18. So there's quite a few of them. Okay, so we're going to pick one. Okay, you got a lot of possibilities here. You got 2, 4, 6, 8, 10, 12 possibilities. You pick one, and what you're trying to do is use synthetic division in order to find a 0 as your remainder. So I'm going to pick -3, let's say. Okay, -3, you put in a little box. You put the coefficients of the polynomial, list them. Got 1, -4, -15, and 18. This is your synthetic division. Drop the 1, multiply the 1 and -3, bring it up. That's -4 minus 3 is -7. -3 times -7 is 21. Bring it up. Okay, 21 and -15 added together gives you 6. And then you get -3 times 6 is -18. And there's your 0 as your remainder. Okay, we found one real 0, which is -3. We got 2 more to go. That power 3, which we talked about before we went on our little break here, we got 2 more real zeros we got to find. But here is going to be your next polynomial, 1 power lower than the given guy. So it's going to be 1x squared minus 7x plus 6 and set it equal to 0. Okay, so now you got, bring this up. So you got x, got to factor this guy. Okay, that's going to be x minus 6 and x minus 1. Now, how did I get that? -6 times -1 is +6, and -6 and -1 add up to -7. If you set them equal to 0, all right, of course you're going to get x equals 6 and x equals 1. And that's how you find the real zeros of a polynomial function. And here's my 3. -3, 6, and 1. Okay? And that's our first example. That's probably as simple as it gets. Does everybody understand? Good job. So we're going to try, I want you to practice some of these, the ones that's simple with the leading coefficient of 1. All right, we're going to do those first. All right, and then we'll talk about the ones that have a number greater than 1 in the front. Those can be a little more tricky. So if you go to page 132 in your books, okay, that will give you some examples like numbers, I will say 11 through 18. I'll give you some practice with those. Those have a leading coefficient of 1, just like the problem I just did. And if you have any questions, please ask.